Hey, everybody. Welcome out to the AI Think Tank podcast. For our sixth show, we'll be talking with Patrick Stingley, who has been a data scientist as well as enterprise architect for the U.S. government for many decades, currently with the Bureau of Land Management, Department of Interior. Patrick and I met through MIT and have also been working together on research projects at InfoScience AI on various patent pending endeavors. Patrick, how's it going? You're in Maryland right now, finally back in the
Yeah,
States. How are you doing today?
doing well, thanks.
Excellent. All right. Great to have you. Glad we could do this. I've been waiting a long time to talk to you on the show, and we finally got it together. So, yeah, we've got a lot to cover. And well, you've been a part of a lot of big projects throughout time. And in my course of knowing you and the stories you've told, I've always wanted to put it together. And I know this show is too small for that. Okay, but we can grace over a few things and talk about data science, AI, and security from your perspectives of having been there and worked with this for many years. Um, and so let's talk about managing some big systems here. You used to talk about how you managed the passport systems for many years, and we're with the White House. Can you elaborate on that some? What that was about?
Sure. Yeah, so I ran the passport database for some years, and actually five major systems
Hmm.
for the State Department. Um, so that was interesting. And with regards to the data science, um, I suppose that was the first of all, the whole term data science kind of surprised me. I
Hmm.
mean, what was the point of doing IT in the first place if it wasn't for the data?
Right.
All all computer systems generate data,
Hmm.
and and I hadn't really seen data science um, emerge as something unique
Hmm.
until AI came out. Really, you know, um, just recently. I mean, with um, vector databases, the process of managing or putting data into a vector database is completely unlike any of the data handling that we've done up until now.
Hmm.
And so yeah, now I'm starting to see a real science of data emerge. Whereas before I would have just called it data processing.
That's right. Yeah.
You
Yeah.
know? But you can't go to a data processing person. You go to a DBA and who's been doing SQL queries for 30 or 40 years and they know how to do SQL queries.
Yeah.
But in terms of embedding, in terms of how you set up the data, how do you even find the data for an AI tool, that's
Hmm.
a whole different set of skills. And before with conventional databases, we'd have, you want to take data from one database and put it somewhere else, put it in a uh, data mart or something like that, or a website or something. You use a ETL, extract, transform, and load procedure. But today with AI, you're not just talking about structured data, you're talking about pages of data, you're talking about streaming data,
Yep.
and now the term is data pipeline
Right.
because ETL really doesn't handle that anymore.
Hmm.
And the whole concept of data science. It's turned into a data science as opposed to data processing, but it's only recent, I would say, in the last 4 or 5 years
Hmm.
since I wouldn't count anything much about AI prior to 2017, uh, to the paper, but attention is all you need.
Right.
Anything prior to that was the old generation.
Hmm.
And in terms of AI and in terms of data science.
Right.
So anyway, it's just been kind of interesting. So when I was working at the State Department running the passport database, uh, one one of the things that made me effective was I knew SQL, so
Yeah.
I could talk to the DBAs and developers and use actual SQL statements in my expressing what we needed to do. And it was fun. I used to I worked at the Situation Room a lot of times during national emergencies because I knew how to speak SQL. I knew how to query the database, and I could find next of kin and all kind of other stuff where occasionally we had to do that.
Yeah.
Um, yeah, I was able to find one person's next of kin from their parents' property records. I mean,
Yeah.
that was pretty obscure, but we found them. And in that case, that was we had found somebody during a emergency in another country, and they were fine, and I just needed to tell the parents they were okay.
Right.
But yeah, I mean, it's I've done some cool stuff. That's one of the reasons I joined the government was
Mhm.
I actually looked at the Tiger database about 20 or 30 years ago. And I said, okay, I want to do enterprise architecture. Well, to have enterprise, to make it worthwhile, you have to have a few systems, which means you have to have a bunch of developers and their various teams. And, in order to have that, you have to have a company. I think it's 25 people per computer, per system.
Hmm.
That you have to have a pretty good sized company before enterprise architecture really kicks in.
Right.
And I looked at the Tiger database, which is the database the government has on what companies there are and what they do and that kind of thing. There were only about a couple of dozen companies that were large enough to make enterprise architecture worth doing
Hmm.
at the time. And I said, well, if I go to work for the government, I can, you know, be work with thousands of computers.
Yeah.
And it's true, it could start almost immediately. And like right now, even though I work in a rather small, obscure part of the government at the Bureau of Land Management, we have 14,000 computers,
Yeah.
so 1.4 million unique kinds of software on the network.
Yeah.
1.5, 1.4 depends on the inventory in that day, but uh, it be it's challenging enough, but small enough that I can get my hands around it, and yet large enough that it's representative of larger problems.
That's right.
Yeah, I mean, most companies will have to go a while before they have 14,000 computers, you know. But because I have 14,000 computers and the 1.5 million pieces of software, I can come up with things like the average computer has about 43 to 45 pieces of software on it.
Mhm.
And when you base that on 14,000 samples, you can be fairly confident that it's representative,
Yeah.
but
Mhm.
when you go to your personal house, your computer, or I might go to my computer and look at it, we may not get that. I certainly won't, because I have all kind of stuff loaded on my computers, but the average person doesn't. And so, it takes a long time before you get to the average out at about 45 pieces of software per person.
Yeah.
Um, this is the kind of stuff that I do. Like I said, like you said in intro, I work at BLM, the original BLM, not current one,
Yeah.
the Bureau of Land Management.
Right. Right.
But so um, I've been thinking BLM is not exactly what you think of as leading edge organization. We're not NASA, we're not rocket
Yeah. I
scientists.
know. Right.
But surprisingly enough, we do have people who are using artificial intelligence.
Hmm.
It's when I originally thought about this, I thought, I'm writing a plan for the Bureau, but my thought was I would die first before they'd ever implement it. But but in reality, no, there's I talked to a fellow this week out in Oregon who's using containers, and he's using AI tools to forecast forest growth or something like that.
Right.
So yeah, he's using it to forecast stuff like that. So you know, that was kind of a surprise to me. But my point is that I see even in a place that's, like I said, it's not the tech hub of the government, but
Hmm.
I still see that AI is there. It's certainly the seeds are planted,
Yeah.
and it'll continue to grow.
Hmm.
So
Yeah, that's right. You showed us, a lot of value in the calculations that you were doing, with your, finding pockets in the ground, and not overfitting. And
oh, the overfitting
yeah,
conversation. Yeah,
that
well,
was so great. Yeah,
yeah, we used that during when we were trying to understand overfitting during the MIT class.
that's right. Yeah,
So
it's a good
yeah,
example
so
though. It's wonderful to know, understand the system you're working with better to actually engage it.
yeah,
Mhm.
I'll express that. I'll go back through that for the people who weren't on that call.
Mhm.
So a problem with artificial intelligence is a thing called overfitting. So I told him the example I could think of, what comes from when I was my undergraduate was geology and meteorology. So in geology, we would try to map an oil reserve, and we would have suppose you had uh, 8 boreholes,
Mhm.
and in the initial 4, let's say, just looks like a square, right? There's four boreholes, and you would connect them. You'd say the oil reserve looks like this. It's just there that connects these 4. But you actually have like 16 boreholes. So you'd have these ones that are sitting way out here.
Yeah.
And now if one out here has oil, do I want that line from front that goes from here to here? Do I want it to go out there to take into account that? Maybe,
Hmm.
maybe. But do I want suppose I have them down here?
Hmm.
Now, do I want the line that goes from here to here? Now we already said sure it'll go out there and contain these.
Yeah.
But what about this one down here? So do I make it go out in here and down a little bit to capture this one and then back out and then over? And well, no. Okay, that's overfitting because
Mm.
the oil just doesn't go that way. The
Right.
oil up here isn't really going to be affected by oil that's down there.
Hmm.
That's overfitting. And so we wouldn't do that. We would maybe do the first or second generation, the first or second, set
Keep.
of points.
Yeah. Yeah.
But we wouldn't try to take into account uh, in these the effective one that's on the other side of the oil reserve because it's not the way it is. Things flow out. They don't. But you have that problem with AI. It isn't in the case of oil. It's pretty obvious. Oil is going to spread out like it does when you spill it on the in the garage. But when you're looking at numbers in AI, it's hard to know when you're trying to take into account that weird number on the other side of the graph,
Oh yeah.
and so that's what we have to be aware of and try not to do in AI, and that's what overfitting is
Mm.
when you try to take into account more factors than really are representative of what's really going on.
Yeah. Because the
So
system just doesn't flow like that.
yeah,
Yeah, I
exactly. It
mean, that's
just
what you're really trying to have an isomorphic approach, something that's truly intermappable with what you're measuring in that
yeah.
respect. And so that means a lot, I mean, you have to. And then another thing, look, a long time ago, I got to see Patrick's resume and just for interest, okay, everybody. But I forgot I asked, and by the time I got it in my email, I thought I was in trouble with the government when I got it. There was so much ink on the page. So anyway, I read down this, and of your certifications and things that you're a part of, there's this one that's really interesting to me every time, and it's the California Earthquake Association or something like that. Could you explain that a little bit? Because land management's really interesting to me here. Uh,
I gotta fix that in my resume.
yeah, okay.
Okay, it's CEA stands for Certified Enterprise Architect.
Right, right, right.
Well, if you didn't get that, then probably other people don't get it either. That isn't going to help my resume one bit.
I
All
am, yeah,
right, I
I'm
guess
just
I should
joking around
spell
with you.
that out.
I am just joking around with you too. But yeah, you have
Oh,
so much to do with a lot of this, geology and whatnot as well.
no, no, it was Certified Enterprise Architect.
Uh,
So,
throw that in there.
uh,
So, Anyway, back to where you're at right now, and some of the things that you've done before through various bureaus. What else could you share with us?
Well, the CEA thing is probably
Yeah,
valuable,
yeah.
because I am a certified enterprise architect, and what enterprise architecture tries to do is to align your IT investments with the mission of
Hmm.
your organization.
Right.
And what I found was that enterprise architecture was typically late,
Hmm.
and inaccurate, and not helpful. And primarily it focused on the big systems that organizations built in-house. But the reality is that the majority of the IT spend is actually on these off-the-shelf programs.
Hmm.
The organization might have a dozen major systems, but it will have the 1.4 million applications on its network, and that represented the majority of the spend. It represented the majority of the risk in terms of security. It represented the majority of the applications,
Hmm.
and yet EA typically ignored these and focused almost exclusively on the custom built apps. So what I did was I got an inventory of the custom built apps. And then because it's 1.4 million, you can't put that in a spreadsheet because you can only go a million rows deep with Excel.
Yeah.
So I wrote some Python programs, and it's actually been part of how I've been studying AI for the last 10 years.
Hmm.
So I've tried a variety of ways to manage the data. And like, well, I went out to Stanford and I took a class on Protege to use the semantic web, what we would call today a knowledge graph,
Yeah.
to handle this data. Um, and that, I can't say that worked that well. Um, I mean, knowledge graphs are valuable and the approach has some merit. And I'll tell you why. You get an inventory of your software. For instance, I have 14,000 copies of Microsoft Word. All right. So Word is a word processor. You can put that into a table because relational tables are based on set theory.
Mhm.
And the set of software, Microsoft Word, belongs inside of the superset of things called word processors. And word processors belong to a superset of things called uh, office automation.
Right.
And office automation includes things like spreadsheets. Excel is a spreadsheet. So all of those things do fine with the is a relationship, and you can put most stuff into a table that way. The problem is the German language pack for Microsoft Word. It isn't a word processor.
Yeah.
It doesn't have the same relationship because it isn't it's a component of, or it's an addition to. Patches, that almost started to say that. Patches aren't a example of the software, they're a patch to the
Right.
software. And so the is a relationship that and the set theory relationship that of a relational table doesn't do well with things like a software inventory. And
Hmm.
so you need to have uh, a more expressive means of, representing the relationship between software than a relational table will do.
Right.
And so so a knowledge graph will do that. A knowledge graph is made up of nodes and edges and stuff, and you can say, well, you can make, for instance, the German language pack is a thing, and
Hmm.
Microsoft Word is a thing, and you can connect them with a thing called an edge,
Right.
which is a component of or is a patch to or something like that.
Hmm.
And you can express that a wider variety of relationships with a knowledge graph than you could with relational table.
Yeah.
And so I tried that, and then it didn't really work that well. Querying it was very difficult, and it wasn't something the average person could do.
Mhm.
But so then the and the other thing I tried to do was, well, when you have well, I had 1.4 million pieces of software. I should say only 45,000 of them are unique, but still it's 45,000 things. So I would rather not look up 45,000 things. And I did actually over time do that, but I tried writing a scraper that would go out to Google and it would send it stuff and look these things up for us and give us back the data. And then we dropped out, they call them stop words. So words
Mhm.
like of and the and stuff like that, they don't really add any value to the definition of what it is. So we would, and Google took limited API based queries to 75 a day. So it took 6 months to query Google for all of these things. But then we took out the stop words, and then I used eigenvectors to figure out what was closest. So, Microsoft Word is close, it's a word processor. So WordStar or WordPerfect,
Mhm.
those things would be closer to Microsoft Word because they're similar and their definitions would have similar words. And so I used eigenvectors to try to lump things together. And again, it didn't work particularly well. Now, we have some AI algorithms that would do this today, but at the time, we didn't. But
Mm.
I tried. I tried really hard to do this. But so even in a trivial thing like an inventory, which would seem relative, like actually, I'm kind of surprised that there aren't that the inventory systems that we have today are so bad at what they do. But
Mhm.
so what this system that I have that I wrote takes the 1.4 million things and it aligns them with what they do. So I use a taxonomy from the Federal Enterprise Architecture Framework, and I align those 45,000 different things with the framework. And so by doing that, I can say, well, here's what all this software does.
Yeah.
And then the the government came up with a taxonomy. They adopted a new taxonomy called TBM,
Mhm.
Technology Business Model, or something like that.
Mhm.
And I aligned the TBM with the FEA framework, and I'm on the TBM Council. So I mean, there were things that they had that weren't aligned, or they didn't. For instance, they didn't even have a category for geospatial stuff.
Ah.
So yeah, so the millions of dollars of money we were spending on geospatial software, we couldn't even show it because the category didn't exist in TBM.
Nice.
So I worked through the government with TBM and got that added, and I continued to work with them until last December
Mhm.
um, to align this. So the government by so this I pop this stuff into I run my programs that I wrote in Python and pop the data into Excel, and Excel uses macros to align the stuff with the FEA framework, and then it uses that to align it with the TBM taxonomy, which then gets reported up to the White House, so
Right.
that the White House can say, well, the government is spending this many billions of dollars on word processing problems,
Mhm.
or something like that. Um, so yeah, that's what I've been doing, and the TBM thing was picked up on by the Federal IT Investment Management Community of Practice a year or two ago, and they considered it best practice in the
There you
government too.
go. You've written a
Yeah.
lot of good things. You have a huge list of publication and things that you've helped enact. I know we talked a lot about the origins of agile development.
Yeah.
You used to take back when that first started, I think you said you came out here to Seattle and Redmond, Washington over here,
Mhm.
met with Microsoft, did a lot of work there. Yeah, it's
Yeah.
extensive. I've seen a lot of, your initiatives and ideas come into play. There's a lot of what's called Stingleyisms out there in your field out that are pretty good. I have a lot of favorites. I know we're kind of jumping around, but there's always a lot to cover with you, and I like to just let it go where it goes. But in terms of really seeing things built and finding ways to do it better, I appreciate your insight. And you've always
Well,
been
that
there with a lot of the fundamentals of how things started and the real history of it. So it's always
well,
meant
that's
so
sort of
much. Yeah.
it was sort of an accident. Most of it was accidental. Most of it was accidental, actually. Yeah.
Mhm.
Like, so that Stingleyism and the thing with Redmond. Well, so in back in the day, um, when they came out with Visual Studio 6, they also came out with .NET.
Oh yeah.
And the State Department where I was working were saying, okay, well, just go buy the new compiler. And I'm like, wait a minute. C sharp is not just C++. It's a completely different paradigm.
Uh-huh.
And we did, just like Java and stuff, we didn't have any idea how to effectively develop in that, and we didn't have any idea how to deploy that or how to maintain it or anything else.
Yeah.
So I went out to a friend of mine worked at Microsoft, and I called him up and I asked him, could I come out just to people and ask you guys how to manage and maintain and all that your .NET stuff? And he said, sure. And he arranged for me to come out. And the guy from Microsoft that worked with him said, before you come out, you got to read these two books. One of them was Rapid Development by Stephen Connell.
Yeah. I got
And
that. Yeah.
and do you have that book?
Hmm.
Oh, that's one of the best books I've ever read. It was just magnificent. And it gave a lot of empirical information about why things work and what things do and what things don't work. And at the time, it was just called Rapid Application Development.
Hmm.
And I went out to Microsoft and I talked to them, and they had a daily build. Every day, somebody writes code, they put it in the build, and they compile it overnight, and they it's part of the build. And while I was there, the uh, the State Department, what do they call it, Passport Services, which is the business part of passports, they published a 2-page passport application. And in the history of the United States, passport applications had only ever been 1 page.
Hmm.
So like nothing worked. Nothing. Our scanners didn't work, our software didn't work. The scanners couldn't even handle 2 pages.
Hmm.
The nothing worked. Like all of our systems were the visa system, everything was impacted by this.
Hmm.
And when I got back, we had a 250,000 passport backlog.
Wow.
Yeah,
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 that's something
it
to.
had piled up that fast.
Yeah.
So I got everybody together and I said, we need to do rapid application development, which we called it at the time.
Hmm.
And we have 5 systems, and they all need to be updated in parallel
It's
all at
epic.
once.
Yeah, I remember this.
And,
Okay.
yeah, and so we got together, and I didn't think that the State Department's development team could go from the way we were doing coding to overnight to nightly builds. I just
Mhm.
didn't think we could do it.
Right.
So we came up with a 2-week thing where we would get requirements and start programming on the first week on Monday, Tuesday, Wednesday. Then we put stuff together and try to get stuff into a build on Friday, and then the following Monday we'd evaluate the results, get requirements, and then at the end of that week we'd be ready for another phase, another loop.
Right.
And that we get everybody together and we would all talk about our different programs. I used SharePoint for the build plan, like what went into the build. I came up with a way of using automated tools. We used Doxygen to
Mm.
read through the code and document the objects. And then we would publish that to SharePoint so that different teams could search and find objects that we had written and reuse them.
Yeah.
And then, later on, like a couple of years later, that process, the 2-week cycle thing, turned out to be a best practice.
Mm-hmm.
And it turned out to be, what agile development is today. It's sort of a 2-week work product thing.
Mm-hmm.
And we were able to rebuild these 5 systems in 90 days.
Wow.
And yeah, and I mean that would have been years.
Mm-hmm.
Under normal circumstances, that process would have taken years.
Yeah, and they're interconnected systems too. There's a certain
Yeah, they're
order where you had to.
interdependent.
Yeah, it wasn't just 5 systems; they were all part of one big system.
Yeah. And
And
then because we published stuff on SharePoint, like different different projects, one in particular, the scanning object, they just found it and reused it. So you didn't have to even ordinarily they would have written another one. But because they had this visibility, then they
Mhm.
were able to reuse that particular component. And the thing that was really cool about it was I had this weekly meeting. We had the build on a regular schedule. Well, about a month into it, one of the program managers, like one of the systems, missed a build. And
Oh.
I talked to the manager and the manager's manager. I said, "What's the deal?" He goes, "Nothing. They're fine." Oh, the next week they missed it again.
Mm.
And so we sat down and we talked to him and found out that the project manager was lost. He had no idea what we were doing, was just completely out to lunch. And we got him around. He came around and he and by the next week they had some trivial thing to contribute, but they were fully able to contribute the cycle after that.
Yeah, good.
And yeah, and they were able to catch up and they were fine. But if we hadn't done agile development, if what became known as agile development, we wouldn't have known that that group was lost until we got everybody to the end,
Mhm.
and we tried to do integration testing, and oh, one of the teams hasn't, they're months behind.
Yeah.
And that used to cost, years in terms of productivity and progress, because somebody got lost, one of their teams got lost somewhere early on, like this one did, and you don't know that until you get to integration testing.
Yeah.
Everybody else has to wait while that other team catches up.
Yeah.
It was huge. And so yeah, so they caught up. And then I developed this 2-week thing, worked in a work product thing, actually worked out really well. I was also doing, the government had adopted earned value management for accounting for development in money. And earned value management, the premise of earned value management was knowing 100% what your requirements were up front before you even start. And then you could do packages of what you were going to deliver all the way along. Well, agile development didn't, well, here's one of those things. When we started out with these systems in passports, we weren't even sure all of the implications that the 2-page passport would have. So I got the requirements people and all of us in a room. We went through the requirements and I told them, look, just give me 60%. Just I don't want 100% of the requirements, because, and here was the Stingleyism, the process of writing software changes the software.
Mhm.
It changes the software because, and so the whole idea of EVM, of having your requirements 100% up front, that was ridiculous. That simply did not turn out to be reality in the software development realm.
Mhm.
Um, but anyway, we got 60% requirements, and then because every loop that we did, we would get the requirements further refined. We would discover new stuff, or this has a dependency on that, or something else. We
Right.
were able to wiggle around until we hit the target.
Yeah.
But that what turned out to be the software we delivered, we would not have been able to have specified that at the
Mm.
beginning. We didn't actually know.
Yeah.
So yeah, so like I said, the process of writing software changes the software.
Hmm.
It also changes the programmer, and it
Hmm.
changes the
Yeah.
requirements, and
Yeah.
and to some extent even the user
Yeah.
is affected. So yeah, I call it the Stingley principle of uncertainty because
Right.
you can't know.
It's
Yeah,
true. It's very sound. It goes with Heisenberg and,
yeah,
even Godell's in there a little bit. So, I mean, and this is such a great approach. And I have found this to be the same thing for me when I've invented anything or a process or approached a very complex system to repair it. I've been in a lot of situations where I had no replacement part or I would have to fix something in vivo. So a part would be refurbished while it's in place and I would have to take it apart just to access its innards, but I could never completely remove it from a machine based on where it was at.
oh,
And I had to, yeah, critical. You can't go back. And so I've had to, formulate some approaches myself, but everything you say is so sound. And you're one of the few people I know who've actually read Eternal Golden Braid from Douglas Hofstadter. And that book had a huge impact on me and my engagement with systems and systems theory, and just how you're interacting with the system will change it and will change you. It will affect everything there. And 60% accuracy is all you need to really have to come close to what the precipice of seeing what's next and engaging that discovery. So I've always found that to be one of my favorite Stingleyisms, and most useful everywhere for me at least. But
well, that gets back to that book by um, uh, Stephen Connell.
mm,
The biggest problem to development is rework. You want to eliminate, to the extent possible, rework.
mhm,
And that's why Agile works as well as it does, is because, when you say, if I had told them, we want to get 80% or 100% of the requirements, we would have written things down that we would have undone later on because that didn't actually work.
mhm,
And rework is very expensive. You not only pay for the development of the rework, you
mhm.
pay to undo the rework, and then you pay to do it again.
Yeah.
So,
Mhm.
and that's from Stephen Connell's book. Is the whole point of that is to reduce rework. So
Yeah.
over about 60%, and anything you think after that is really going to end up being rework.
Yeah.
So yeah,
I've seen that. I've seen that. I've had to seen too much of that and things that occur later in systems. And I know I help vendors fix their systems with robotics and things like that. And then I would ask for a feature and I would buy the book, like, multimedia command codes and find ways to actually tell them how to do the thing I want them to do. They would do it. It was amazing. I would be the only person around for a while that had the machines like that. But there were so many things in these complex systems they would miss. Weird stuff that would happen, and errors in logic, okay, between firmwares getting messed up or different circuits getting completely messed up along the way. You had static, you had external systems and other things like this. So there was a part of the system there, a little piece of wire that I installed on every one of these parts gave it a way to ground out and not mess up the electronics, right? They didn't see all of this. There's so many levels to these systems, and where people test a system and how can completely change the results compared to where it might be in a different environment. We all know this, but it can be really extreme because sometimes you can get a 0 and a 1 mixed up, and there's no error, and something happens, an exception goes down the line, and that's really where you can't think you see it all. And 60% is really important, is to say, well, there's no hubris here. There's a lot we can't see and a lot we have to look at going down the road to absorb. So I love that discovery mode thinking. I love that investigation aspect of it. I think it's a lot of fun, but especially when you have to make it work, there's no going back. It's critical. It's mission
yeah.
critical, and for you, some of the highest levels of that. Um, I can only imagine the pressure that you've been under in those circumstances. So,
It worked well. It was the first time we'd ever done it, and it worked well. So, but anyway, I learned a lot about project management in that regard, in that process. Um, I learned a few other things. For instance, it was very because we were under the gun, there was this incentive, and Agile worked very well because we needed to get it done and everybody worked well.
Mhm.
What I found was that over the year after that, it really kind of fell apart. Agile works really well in an emergency, but if you can't, it's like crying wolf. You
Mhm.
can't continue to cry wolf and have everybody feel the same urgency. You got people burning out, you get people that simply won't do it anymore.
Yeah.
Um, yeah, so Agile turns out to be difficult to maintain long term. Now, I also learned another thing during that trip, which was that worked out really well for me. Um, I was there, and I went to Fry's Electronics, and I bought this book on on Microsoft servers, and Microsoft had a suite of servers at the time, and they still do. One of them was, SQL Server, and then Outlook, the email server, and one of them was BizTalk.
Mm.
And there were five of them, and one of them was BizTalk. And I came back, and we got done with this business with the getting the passports online. And then that was about the same time they were standing up DHS.
Mm.
So DHS came to us and they said, we want it so that when somebody comes into the country, we can swipe their passport, and we want to go right to the passport database and see what shows up from the passport database. That way we'll know if these people have a phony passport.
Mhm.
Well, up until then, building a system of that magnitude would have taken about $1 million in about a year to do. And I said, well, why don't we try this with BizTalk? Why don't we, it's a flow. You can just take the passport data from the person from DHS and bounce it off a bunch of our systems and send it back.
Mhm.
And I got approval, and we did that. And it took about 6 months and a half $1 million. And which was in itself a savings. But after that, Interpol came to us and said, well, we want the same capability when people arrive at our countries. So it took us an afternoon and about $1,500 for that second system.
Whoa.
Yeah.
Yeah, that's
So
yeah, I remember this now. That's
yeah.
incredible.
So my experience, and that later this became known as business process management, BPMN, or
Uh-huh.
business process management, or workflow approach.
Mhm.
And so I, I went from like the waterfall method to agile development to this sort of low code development approach. And
Mm.
my experience in empirical data shows that workflow based or low code approaches are 2 orders of magnitude more efficient than even the most agile development approach. I mean,
Yeah.
it was that, I mean, $1,500 compared to
Right.
$1 million,
I bet they
you
were
know,
happy. Yeah, I bet
they,
everybody was pretty
yeah, it worked
happy.
out great.
Uh-huh.
I, I haven't, I've written things about this, but I haven't really, adoption has been very slow, over
Mm.
the last, I don't know, that 15, 20 years, since
Yeah.
BizTalk. But, I think people are kind of catching on.
Mhm.
Uh, so, part of the problem with IT in an organization is that the process of writing code for an organization is so costly and laborious that they only can automate about 10 to 15% of what an organization does.
Mhm.
The programmers just don't have time to do more than that. So with low code approaches, people can actually automate their own processes.
Mhm.
And I think there's a lot of value to that people would be able to automate their own processes, and the beauty of doing it that way too with a workflow is that the person can automate the work processes, but the managers can see what the work process of their people are.
Mhm.
You know, I've had people when I was doing enterprise architecture, I had people come to me and say, you know, the people that don't know what their processes are. We need you to write down what their processes are because the people don't. And I was, they were, you know, in their glass office, like being in the glass house, you know. I walked out of that meeting and they were still talking. It was very disruptive, but I walked around. I went to the room, the break room. I went to a bunch of people's cubicles and I just picked up workflows off the walls.
Mhm.
And I walked back into the meeting. I said, no, these people know their business processes. They've written them down. Here's the flow charts. The
Yeah.
people who don't know the business processes are you, the
Mhm.
management. You don't know their business processes, but they know them very well because they have to live by them,
Mhm.
you know. But
Yeah.
you know, yeah, I think so much of my life, people, you know, you lead the horse to water, but you can't necessarily make it drink.
I know. That reminds me of a really great security story you were telling us the other day, which was oh, maybe this comes down to the whole what is really zero trust anyway? Because at some point you have to trust somewhere, but where you do has got to count the most. Yeah, what was it a few months ago? I don't know, it wasn't too long ago, but you had a presentation that you did for Department of Homeland Security using your own laptop, I suppose. You want to tell us about that? I thought that was a real good eye
It's
opener. So this
kind of a
was
difference.
local open models and some security concerns.
Yeah. Well, there are a number of. So I wrote the zero trust plan for our organization. And you know, here's an example of can't lead the horse to water. There is no um use case for where if you suppose you have, you know, any number of people, 5 people of 50 people, all of them working for your company.
Mhm.
There is no use case where person A's computer should talk directly to person B's computer. If I'm sending you files, I send them to a file server. If I'm sending you email, they go to an email server.
Mhm.
You know, there's no reason. If you imagine you and I are sitting cubicle to cubicle, there's no data that actually goes from me to you directly.
Right.
Nothing,
Yeah.
right? Um, so the cheapest, easiest, least cost, least risk thing you could do to give yourself zero trust is to put everybody on full bit masking.
Mm.
Okay, so on IPv version 4, an IP address is 32 bits.
Yeah.
And if you make a 32-bit mask, it sits, your computer sits alone on its own network, essentially,
Mhm.
right? If you do that to all of the computers, they all sit alone, which forces traffic between you and me to go to the router. All right. So if I have a virus on my computer and I can go to the router and the router's rules will keep it from attacking your computer, as opposed to if we had 8-bit masking or 24-bit masking where your computer and mine are on the same network, well, that a virus on mine would be able to find you directly and talk to you directly and
Mhm.
attack your computer directly without being monitored or supervised by the router. It would handle all at the switch level.
That's right.
You could easily implement this on most routers, certainly the ones that most businesses use. And because of a property that they use these days called cut through switching, which what cut through switching is the first packet gets routed, but all subsequent packets get switched. So they go at a high rate of speed without having to figure out the path.
Mhm.
So there's no real overhead, and yet you get all the protection, and it costs nothing.
Mhm.
So yeah, but to try to you know tell people try that, you know, it costs nothing and it'll work. And then I went to NIST and I said, well, what about um, Microsoft Windows or Linux, well, first Microsoft Windows. So what about the identity management of Active Directory?
Mm,
Well, is not adequate for zero trust.
right.
And the answer is nothing. Nothing. They told me to my face with my boss on the line. No, it's adequate for that. All right. Well, what about the permissions of Linux or Windows, so that somebody can't break in? You have especially with Unix, you have personal, users, groups, or global permission. What about that? It's not adequate in terms of protection. And the answer was nothing. And okay, well, what about data at rest? What about the BitLocker that comes on your Windows box? Is that inadequate? Well, no, actually, that's a best practice according to the NSA.
Hmm.
All right, so all these people are trying to sell us all this zero trust software for millions and millions of dollars.
Right.
The function's already there and it's completely adequate according to NIST.
Yeah.
So, yeah. So I did that and I came up with an architecture that isn't uh, expensive. One
Mm,
one of the one of the problems any organization has is keeping uh, people from just loading software on their network at
right.
will, you know. And so I recommended a whitelisting service because a whitelisting service will only allow the things that are on the whitelist to run, which would keep things like viruses from running.
Hmm.
And it also gives you a good configuration management baseline because if it's on the whitelist, somebody's tested it,
Yeah.
as opposed to stuff that's not, that's just on there. So that would help you to sleep at night. That even if somebody sticks something on there, if it's on the whitelist, at least it's been tested. And if it's not on the whitelist, it won't run.
Hmm.
So that turns into a fairly easy way to accomplish zero trust. But anyway, getting back to the stuff you and I had talked about before. So I did all that, and then I sat at my desk, and they didn't have the whitelist, but it doesn't much matter. I wrote a ping script to go out and find all of the computers on my network, and I scanned the entire 10net, which that's 65,536 networks of 255 computers
Hmm.
each. I scanned all of those, and then the 172.16 and the 168 networks,
Hmm.
and then I subtracted the ones that had valid host names and found 2,000 IoT devices on our yeah. So I mean, think light bulbs and cameras and security cameras and all kind of stuff are these IoT devices. And many of them just have terrible security.
Yeah.
Some of them even have web pages.
Uh-huh.
You know, the
Right.
whole point of a web server, the point of a server is to give control to somebody else. That's the point. If you look up the definition of a server by its nature gives control to somebody else. So
Hmm.
if you have an IoT device with a web server, its nature is to give control to the user,
Hmm.
and they can easily be hacked.
Right.
And a significant number of denial of service attacks are coming from uh, IoT devices these
Hmm.
days.
Yeah, even vacuum cleaners have it.
Right. Oh,
Vacuum
everything.
that have
Yeah,
Wi-Fi in them. Yeah, there's all. Yeah,
right.
working with devices for so many years and building things that work, some from scratch, some very small. I've seen a lot of potential misuse. I've always
Or
protected systems. I was hired as a hacker a long time ago, but a good one. I'm a white hat. I protect things, but in the course of it, you have to do a fair amount of red teaming to really understand. And so, pen testing and everything like that's crucial.
right.
And you had mentioned a proof of concept that you had put together. I think it was with correct me if I'm wrong, it was on your laptop and it was using I think it was Llama 2 and you had
Oh yeah,
produced
I was going to get to that. I was
yeah.
getting to that. So I did the IoT thing,
Mm-hmm.
and the fact that I could the fact that I could talk to all the devices in the network without the security people being aware of it
Yeah.
pointed to a problem. And so if we had been using Tripwire, well, I think we would have picked that up, but we
Mhm.
weren't. Tripwire is a free software that
Yeah.
monitors for aberrant behavior. But the problem with it is that it requires a person to sit there and pay attention to what Tripwire turns up. Well,
Mhm.
really, there's a good application of where AI ought to be, replacing or augmenting that person so that when somebody does stuff like I did, it's picked up. And
Yeah.
and right now, if I can do it, so can
Yeah.
any given virus, right? Any given virus is going to look
Right.
for other computers to break.
Uh-huh.
But anyway, back to what I was saying, that AI, I've been talking to DHS, and I've given this talk since the 22nd of March several times.
Yeah.
And I said, look, here's where you are. A year or so ago, I got Kali Linux,
Hmm.
because Kali Linux, if you don't know this, is the toolkit for writing viruses.
Yeah.
And I loaded it up and I wrote a few viruses, and just to figure out what I was doing. And then last November, I got Llama 2 running on a laptop because I
Mhm.
want to do this on the internet. Um, with the idea that I would take the virus code out of Kali Linux, and I'd feed it to Llama 2 to make um, have Llama 2 write new viruses,
Mhm.
unknown viruses, previously unknown viruses. Because Llama 2 is a generative uh, large language model tool. So it doesn't care what language you give it. If I'm giving it assembly language, it'll spew out assembly language just as well as it'll spew out English.
Mhm.
So the idea is to feed it into Llama 2 and have it generate new viruses. And then I would write a digital twin to capture those viruses so we could kill them. But
Wow.
since then, I became aware of the GAN architecture,
Mm.
generative adversarial network.
Right.
And that basically does the same thing. The way a GAN works is it has a generator, which
Mhm.
in this case would create viruses, and it has a discriminator, which would recognize, kill, and capture viruses.
Mm.
The way GANs are used today is with images, your Dolly and those sorts of things.
Right.
They have a generator that generates an image, and
Yep.
they feed it to a discriminator, and the discriminator, if it can figure out that it's computer generated, it throws it away.
Mhm.
But eventually, and it sends message back, no, that wasn't good enough, and the generator generates a new one. And they bounce back and forth, training the generator to create more and more lifelike images,
Mhm.
and at the same time, tr- training the discriminator to recognize
Yeah.
more and more lifelike images
Mhm.
until the generator eventually creates something that the discriminator doesn't recognize as computer generated.
Mhm.
Same approach works with viruses. Send these computer generated viruses to the discriminator will tell the generator, no, write better ones. And the generator will create better ones until it passes the discriminator.
Right. Right.
Now, all of these are 0-day viruses. They're
Mhm.
your current antivirus software. The way it works is it recognizes viruses it's aware of.
That's right.
And they call that a signature. They look for a certain pattern. They go, oh yeah, we know what this is, and they throw it away. All of the viruses that I'm talking about from the AI are new. They're all what they call 0-day
Mhm.
viruses, and that's because they've never been seen before.
Right.
So current
Mhm.
antivirus software will be unable to protect us against these viruses. And I would say we have we're going to be uh, subject to these attacks for about the next 6 months until
Mhm.
generator discriminator based antivirus applications become commercially available.
Right.
And I would say that that's where we really have to go in terms of in terms of security,
Hmm.
because the ability to create zero day, and I call it viruses, but I should say exploits, because
Yeah.
I could write things that exploit web pages or exploit, all kind of ways of getting into
Hmm.
computers, not just viruses. But
Right.
I would see them that for the next 6 months, it's going to be a mess until the discriminator based anti-attack, anti-exploit tools
It's going
become
to take
available.
going to take real-time GANs. It's going to take a real-time
Yeah,
general
yeah, it
adversarial
will.
network on one end that takes knowns and then works with a lot of reported knowns and then starts its own reports. You know, that's a that's a deep conversation. There's a lot of security concerns out there for even just, beyond endpoint to endpoint. We have with large language models and their training data. I think that we do our research. Okay, we work on various projects. We talk a lot, and later I have some things that I'm gonna have to look at with the team and wrap my head around because I might have something, really incredible, or I might have some drivel from an LLM. We'll see. But it's amazing. I know that I was talking to our good friend Caleb Stevens out there. He's been on the show before. He's actually with us right now in the audience, talking about how easy you can still get a lot of models training data and by using other more powerful models to extract this in um, a very hidden way to the target LLM model itself. And
Mhm.
so I even last night in my testing, and I let it go for a while. Um, it was incredible how much information it came up with that looked like a quotation for pages of unique information, based on some conversations that happened before. Anyways, I don't want to go too far down that road, but there's a lot of exciting things going on right now. And in security, we've found, different types of networks have good support. There's some people that I know out there that are with Tenable, and they provide a lot of network security for Azure networks, and there's a lot more you could see there. But on the small of things, we have this layer of security that sits really close to the user. And that's where things get defeated most of the time. I mean, Patrick, you told me a story once where you had one of the government servers was running was it Lotus 123, or you had a Lotus Note system set up? I forget what it was. And
Yeah.
that was being used for other applications. Am I right? Do I have that right? Or,
Yeah, no, it was surprising. Some
uh-huh.
of the old stuff that was still there. Yeah,
Explain
I
how that
find it
was
every
done,
so
what that
often.
was. I know it's not clear to anybody but a handful, but how- what are we
Well, I
talking?
think the inventory picked it up.
Yeah. Yeah.
Do this inventory, and yeah, I found stuff like that out
Uh-huh.
there on the network. Now, I mean, we've cleaned it up since then,
Oh, sure.
but
Yeah. But there's just a lot of places that you'll be surprised to find where things can go. And especially with, where AI is right now and how quickly it can adapt. Even with local hardware now, you can create code pretty quickly. Whether that works or not is to be seen, though. Okay. So, and that's important. But what does work and what you can test is, now's the time to get it out there. There's a lot of people working at various ends of security, whether that's, with deep fakes out there. I know we have a lot of people out there interested in defeating that, and there's some good people out there who know what they're doing that have put together some great frameworks for approaching what would be that type of security for authentication and avoiding, all kind of things out there that can happen with deep fakes and other types
so
of general
you said
adversarial
you
networks. Yeah.
you said you were doing red team testing and penetration testing. Did you ever try Metasploit?
I did some. Yes, I did. I did that on
I
the
mean,
local network
if
somewhat.
anybody hasn't tried Metasploit,
Yeah, it's
I
really
mean,
important. It's a very cool.
well,
Yeah.
so no, but Kali Linux is based on Metas. I mean, the hacks in Kali Linux were commercialized and turned into Metasploit.
Hmm.
Okay, they got the hacks from Kali Linux, and they wrote a really good tool. I mean, if you go to Metasploit and you say, I want to break this Red Hat Linux box, it will write the assembly language and shoot it over there and give you the root prompt.
Right,
And
right.
yeah, it will. And so my point is, when uh, when these hackers can break into people and organizations and make $75 million in a day's work,
Yeah.
they they can hire really good programmers. And
Hmm.
and these tools like Metasploit are very good. If you've never seen Metasploit,
Hmm.
it is for breaking into computers what Microsoft Office is for word processing.
Yeah,
It's
absolutely.
every bit as
I,
professional.
right, right. I've intercepted things from that. I used to do a
Yeah,
lot of QC and QA for digital devices. I'm a device hacker. I love tinkering and breaking stuff and putting things together, but also finding in the nooks and crannies viruses. And so when let's say 3,000 to 10,000 of these chips would come in, I would start doing random spot checks to certain ones. And lo and behold, I would find viruses that were a product of what looked to be a Metasploit operation coming from them, and hidden, outside the partition in such a way that Microsoft wouldn't see it, and a Linux
yeah.
machine would see it. Some machine,
Oh,
it just
okay.
really depends. And so there's so many ways to hide data in and around a file system, just mosaics, stenography, Slack space. There's a whole Linux. Do you remember Slack Linux back in I think
Remember it. Yeah.
uh, in the early 2000s, it was definitely had some good steam, but it just used the Slack space in your file system to store itself. So it was like a dual boot situation, and things have come a long way since then, but localized exploits are so powerful. And imagine, let someone uses Metasploit for an internal exploit where they put it
Right.
into a USB key walk-in,
Well,
or,
that's not
you
true.
do Wi-Fi.
Or they hack your external website,
Mhm.
and use that as a way of launching an attack inside the organization. Once it knocks over it gets root privileges on your website, it goes in and it uses that to attack internal systems. And that's the thing that has me the most worried about zero trust. And I've talked to the people at CISA about this. Zero trust says we're going to get rid of trusted domains. Okay, and you want to have specific, unique security for each device. That's fine. But
Mhm.
I don't feel comfortable that I could be sitting in my desk and the web server for the organization sit right next to me. And they're not in a DMZ because we just got rid of them for zero trust.
Yeah.
I'm like, no, I I do not believe that. I believe I still want to have the web server in a DMZ so that if somebody knocks it over, they can't attack the rest of the computers in the organization.
Right, right.
And
So,
no,
yeah, we got a big question for you here in this, and Caleb brings this up. Caleb has a question. You want to ask this here real quick?
Sure, I would love to. Hey, Patrick, good to see you again.
hey, Caleb, good to see you too.
Um, so one of the things that I um, have noticed just in doing some training and things on small models locally is there is the ability to slightly alter the AI's behavior by hijacking the training data and providing almost like correct data to the AI. You can essentially make it useless at a specific task, which would generally be unnoticeable by everybody else, right? But you pick one task and you say, I'm gonna just slightly corrupt this training data before they initiate their new training sequence, and the AI accepts the training data. You ask it a couple of questions or you do a couple of tests against it and it tests okay, but as it goes on, it relies more and more on that corrupted training data, and then the AI becomes useless at that task. Now, obviously, this isn't something your normal hacker would be able to do. They'd have to penetrate deeply inside, OpenAI or these other places that are doing the data training for the AI. But it is most certainly a possibility. Is it something that you've seen or heard about?
I was asked about that by somebody at DHS, and they were asking me in not quite the same terms. They were asking me how would I implement guardrails on a system. And the way I don't think, now you can correct me if I'm wrong, but I don't think that they go and change the algorithm to implement guardrails. I think the way they do it is by feeding it data like you're talking about,
Yeah.
and using a data-based, not database, but data-based approach like you're talking about, where they feed it the kind of information they want, and they reject the responses they don't want. And that's sort of the same thing you're talking about, but I think that's how guardrails are implemented.
Yeah,
Am I
and this
I'm right
method
on that, aren't I?
would get you past those guardrails, right? Because you would be able to show mostly
Well,
correct information, and your
yeah,
reviewers would
yeah.
see it
You're
and say,
saying
okay,
that you're using the same approach they use to implement guardrails to make the thing do something it shouldn't. But
exactly. Yeah.
I'm just saying, yeah, of course it's going to be susceptible to that. That's that's how they should implement guardrails in the first place.
Right.
And you know, that's one of the issues with synthetic data, which was another tangent thought to what you were talking about. And that's, you know, when you create synthetic data to train these models, how do you know that you're not causing drift in the model?
Mm.
Yeah.
I think that's a real risk. I don't know that there is an answer to that except a human in the loop. You know,
Yeah.
you have to go look at the synthetic data and see that if it's not drifting your model in a direction you don't want. The same thing with your point. Like suppose you had a you know a red team or invader or something like that come in and start feeding bad stuff. Didn't that happen to GPT-2 or something like that? They started getting it to say all kind of um, you know, like Nazi stuff and things
Oh
like that.
yeah, yeah,
Yeah.
something like that.
Yeah, they started feeding it
Hmm.
all this terrible stuff, and it started, you know, using that data.
Hmm.
So I think there is I don't know that current LLMs have a way of protecting that, but hopefully there. I actually have seen there's a type of AI used to filter the data that goes into LLMs. Um, I, I don't remember what it is right off the top of my head, but let me see if I can pull it up. But I think that what they've done is implemented an AI as a front end to to training the data to so that they can filter that stuff out to keep people from doing just what we're talking about. Uh, let's see. No, it's not on this
When
computer.
I think about that, I think about Stuxnet and, you know,
Oh
the
yeah.
very minimal amount of changes
Hmm.
that were made and so unnoticeable until it caused a problem. Um, and that's how I imagine an attack like this being used. You know, say you don't want your adversary to advance their research as quickly with AI. So you give it just enough wrong information where the answers are mostly right, but it does set them back a bit because now they have to go back and look at additional data. So you could hijack, you know, adversarial AI or another company's AI that's helping them advance and slow them down by corrupting that training data.
Yeah,
Hmm.
I'm my computer is going nuts right now. Let's see. Let's see. Hang on. Control. How do I do this? Control F. On. No, I can't get it to work because global protect is going around in circles, taking over my computer. The VPN software that we're using is just making my computer nuts. All right, no, maybe I can do it. Hang on. Look for uh let's see. No, what do they call that? Um,
And while Patrick's doing that, Caleb, did you get a chance to look at Llama 3 Gradient?
I had not had a chance. I started tooling around with Llama Code after we talked,
Yeah,
and just having a blast messing with that and using Olama to try to connect other things. So yeah.
right. Good. Excellent. Yeah, it's been a super productive week for me, and so many good results and amazing findings. It's like being a kid again and finding like just a little buried treasure map or something. Just
Yeah.
imagination goes wild. But yeah, I've got some interesting things for another meeting. Yeah. Outstanding. So anyways, I love being on staying current with all this. I mean, and seeing things as they come out is so amazing.
Yeah.
One of my favorite
The
parts about
GPT event is scheduled for Monday. I don't know if you saw that news
tell
announced.
everyone about this. This is a great time to do that. Go ahead.
What's
Yeah,
that?
so ChatGPT is going to be launching an event, or OpenAI will be launching an event on Monday where they expect some additional feature and possible product announcements that'll be coming out.
Okay.
My expectations is it's going to be a general release of their Assistance API and likely some additional features implemented around that
Okay.
that I've just seen on the beta end that they're likely going to be making more public.
Yeah.
Um,
Right.
that's
I've got
my
some guesses.
assumption based
Yeah.
off of what Altman said on Twitter. So
I have some guesses I'm going to keep to myself, but I'm rather excited about my guesses. We'll see. I just want
yeah,
some modular plug and play type stuff. I'm
yeah,
sure.
exactly.
Uh,
Some better tooling around the functions would
right.
be incredible.
Yeah, it would
So
be. Yeah, absolutely. Let's see here. Patrick, did you find that?
I did not. I
Okay.
did
Well,
not.
we can bring.
I'm continuing to look, but it seems to me
Yeah.
what they do is they use a different kind of AI tool algorithm
Hmm.
as a front end to the LLM. So because uh, they can give it good algorithms for screening out bad stuff.
Right.
So yeah,
Hmm. Right. Absolutely. And on the note of, viruses and things like that, I mean, it was so easy for me to write Python code that was, like an extension of talk chat with your files that I had wrote during class a long time ago. Um, and give it the ability to read and write and delete files on the system with root privilege. And, it's just so easy to do. Um, and I can only imagine what someone would do out there, especially in a local environment with something like this. But it almost doesn't matter though, because you could do it remotely as well. But anyways, um, there's a lot to protect, no doubt, and from every angle. And Caleb, I remember back when we were looking at guardrails and protecting our bots from being robbed of their prompts, robbed of their data,
yeah,
and so that was something it worked for a while, and then there was another way in, or you discover another way to word something. It never was set in stone, but now we're getting closer to some better security through different practices here. Let's see, what else do we want to cover? We got a few minutes left. Do we have any
I
other
found
questions?
a DB scan,
What's that called?
a DB scan,
Oh yeah,
density based clustering is
uh,
used to
here we are.
feed into those things. So a density based approach, a DB scan puts stuff together if it's kind of like k-means.
Mhm.
It puts stuff together with clusters of data, and they use that as a means of filtering the data before it goes into a LLM
Right.
because it's sort of context dependent. They put things together. Um, yeah, there we go. PCA is an unsupervised learning algorithm, but it has also been widely used as a pre-processing step for supervised learning algorithms
Hmm.
because it derives new features by finding relations among among features in the data. So, in other words, if you have uh, your data and you start filling in, submitting Nazi propaganda,
Hmm.
it's going to lump that together with other Nazi propaganda and allow you to filter it out uh, of the corpus
Right.
behind the LLM.
Mm-hmm.
Yeah,
All right.
DB scan clustering.
Mm-hmm.
Yeah.
We've come a long way since Llama 2 already.
Well,
And
yeah, I think that proved the point. They needed
yeah.
something.
Right. I mean, we have on the micro end of things, I don't know if you've got around to testing it yourself, but I use Code Llama 3 7B, I think. I forget, maybe I'm saying that wrong, but it's the small 3.7 gigabyte sized image of a model that you can get and use on Ollama. And it did a fair job of, generating usable code. We did that together at one point. I know we were looking at that. And now I'm trying those larger context windows. And so again, it's only a matter of time before we have to, level up our tools on every side here. So, and that time is now, really. So, I'm looking forward to trying some of these more defensive hacks out to see what we can get. There's a lot of angles. I know you have so many strengths in this, Patrick. I have a few specialties in this. But just a drop in the bucket compared to your actual security endeavors and experience over time. So, I mean, how long would you say you've been in the field of, systems architecture for, secure purposes? I mean, most everything you've touched is usually mission critical. Am I right? You're always with
Yeah,
a live system, it seems like.
yeah.
Mm-hmm.
I'm trying to think back on
Mm-hmm.
how far back. Oh, I know. That was in, yeah, I was a security consultant on the Philadelphia Stock Exchange.
Mm-hmm.
And at the time, firewalls were not common. So I got the firewall toolkit um, and built a firewall for them, a proxy firewall,
Yeah.
and using a Solaris box as the host. So I'd say that it was then, and I got the book. The book for that was called "Repelling the Wily Hacker" or something like that, written
Oh,
by a couple of folks from Bell Labs, and it was sort
okay.
of it was like the in the initial or in what the seminary book on IT security.
Right.
It's where we get the term firewall from,
Mm-hmm.
because he wrote down, like a firewall in that building, you want to have a separation between one thing and another.
Definitely.
And most of the much of security thought actually came from that book.
Mm-hmm.
And the book was basically a cookbook for how to build a the firewall toolkit into a working application firewall.
Mm-hmm.
So I did that, and I learned a lot about security at the time, but I also learned, that there's just some basic principles that if you do them, will keep you out of trouble. And if you don't, implementing them later for security purposes becomes very costly.
Right. Right.
It really doesn't cost that much different to build a secure system than it costs to build anything, right?
Mhm.
But
Right. Right.
but like okay, like writing your code with if you're writing Python with try and except statements,
Mhm.
it's a little more expensive to write a try and accept statement, but it's a lot more expensive later on if you've published this code to go back and put it in,
Yeah. Yeah.
you
Absolutely.
know?
Start now. Build the foundation now before you go for the attic and the roof. I mean, it
Yeah.
should be common sense to, on the large these days, but you'd be surprised, how things
The
go.
majority of hacks are really buffer overflows. And
Uh-huh.
that's ridiculous. We've been doing coding now for 60
Mhm.
years. It should be the first thing that you do is try to, or make it so you don't have buffer overflows.
Mhm.
But it's
Right.
still that's the principal cause of most computer hacks is overflowing some buffer somewhere. And what does it cost to protect against a buffer overflow? Not a whole lot. It's pretty easy code,
Yeah.
but try to go back later and put it in, and it's always, expensive and
That's right.
awful. And yeah, and and the same thing goes with anything in terms of architecture, the laying out the code, the laying out the network for security. It isn't that much more expensive. But I tell you what, I've been in organization. I was in an organization that had, multiple classifications of security,
Mhm.
and they were too cheap to buy two NAS devices.
Ah,
So they would have one, the classified part in one half of the NAS, an unclassed part in the other part of the NAS. I said, I don't care what you spent on your firewalls, the security of your organization is no stronger than the BSD operating system in your NAS.
yeah,
You
yeah,
know, and
that's
the BSD Berkeley Unix was
Mhm.
not built for security. It was built to be cheap and it was built to be easy to work on. Security was not part of the concern. It was about sharing information.
Yeah.
So, but you see that all the time where people and I'll tell you, here's another one of my Stingleyisms. I might not be mine, but I use it all the time.
Mhm.
Is that security is like virginity. Once you lose it, I'm not sure you ever get it back. You go back to the cuckoo's egg, right? The Clifford Stoll book. The
Uh-huh.
guy, he planted this cuckoo's egg inside the secure domain, and he could attack anything he wanted. You can, if you apply security after the fact, how do you ever get it out? How do you ever get a clean environment again?
Right.
I don't know that you do.
Uh-huh. It's like a data
You know,
breach, of any sort. You're left with what wasn't affected, what has
but
been.
you don't know if they're good at what they do. You'll never know. You
Mm.
know, they no, they put it in unused sectors. They put it. You don't have any idea where whatever it is might be lurking.
Mm-hmm. Yeah.
And how expensive is it
Uh-huh.
in that situation compared to what it would have cost to do security right in the first place?
Right. Again, I've had to come up with ways to put data on things that's in an invisible format so that I can trace through various systems for the sake of quality control where something went and where it came from. So I'll give you a really odd example, but there's just so many ways to do something. Now here I'm using it to help a system, but you could easily do this to hide other information, maybe parts of a crypto key. I don't know. So I had these duplication machines at this time, and so we're talking about CDs and DVDs, and a machine could hold 1,000 discs. Okay, so it had four spindles that would hold about 250 discs, and then one on the side that was empty. Okay, and so it's for software distribution and packaging. And so I wanted to figure out what drive a DVD or a CD went through and where it was failing in a system. So you could look at the end of a job and say, well, this drive had 12 failures. This one had this, but you don't know what disk and for what reason. And when you scan that and you do quality testing after the fact, then you can see why. But you could never match those things up. We needed a vector here. So we didn't have that. So here's what I did. I was able, and this is down the way outside of the its own environment, so I could tell what machine something came from. So I would take ultraviolet ink and use a type of Morse code I came up with and affect the edge of the disk where you're not even supposed to be able to write data, and no one could see it but me with a light. And so way down the line, if something happened or something came back in the mail, I could take a disk that a client had and look at the edge of it, right? And I could see where it came from. And
Right.
so I got some good accolades for that. And so that was my environment for a long time, just to, create solutions to do quality assurance. And I found a lot of tricky ways to do it. Now you can take the same tack to hide data. You can take the same tack to hide a key or, part of something else, part of a program. It's incredible what you can do. And because I work in graphics and I worked in, video, digital forensics for video and images, I've been able to see and apply a lot of other techniques as well. That's why I came up with that. That's why I came up with a project called Deep Fact a long time ago, just as a big proof of concept. But anyway, of course, there's a way around that. So anyways, look, so it's 11:30 here for me, everybody. That's an hour and a half in. I'll tell you what, if anyone has any more questions, go ahead and ask now. Patrick, you have any closing thoughts on and words to everyone out there for security reasons, or what you expect going forward right now?
Well, like I said, I expect the
Uh,
next 6 months to be terrible
yeah,
until we
yeah.
get until the discriminator-based AI based anti-attack systems become available. But
Mhm.
otherwise, no, it's been fun talking with you, and
Right.
I've thoroughly enjoyed this. It's fun.
Oh, yeah, absolutely. Me too. Yeah, I have so many things I want to go try now. You've got me thinking. And don't worry, I'm not going to play any pranks at the lab. Okay. Anyway, so well, this has been fantastic. And I just want to thank everybody for coming out and being a part of this. Patrick's been a wonderful friend, a wonderful research partner, a mentor. And I just can't get enough of your stories. And, we'll probably see you back on again, maybe with the rest of some of our crew, and to check back in on where things are at in the world and with you. And I look forward to whatever we do next. Again, thank you so much.